In this video, we're going to introduce the Analog Discovery Voltmeter instrument. For now, we're just going to use this instrument to measure constant voltages in our circuits. This is our representation of the connectors on your Analog Discovery. The Analog Discovery Voltmeter has the capability of measuring two different voltages, channel 1 and channel 2. Each channel requires two connections since we're measuring a difference in voltage between 2 points. The channel 1 connectors are 1 plus and 1 minus, and the channel 2 connectors are 2 plus and 2 minus. On the Analog Discovery, the 1 plus terminal is connected to an orange wire, and the 1 minus terminal is connected to an orange wire with a white stripe on it. The 2 plus terminal is connected to a blue wire, and the 2 minus terminal is connected to a blue wire with a white stripe on it. Displaying the measured voltage difference is controlled by the voltmeter instrument in the waveform software. To open the voltmeter instrument, simply click on the More Instruments icon on the main window and select Voltmeter from the resulting drop-down menu. The voltmeter instrument is extremely simple. It displays the voltage difference between the two channel 1 terminals or the two channel 2 terminals. The different types of voltages are displayed by the voltmeter: DC, True RMS, and AC RMS. The DC measurement is the most appropriate for constant voltages, while the other two options are more applicable to time-varying voltages. Since we're only interested in constant voltages at the moment, we'll restrict our attention to the DC voltages. Now we need to talk a little bit about the signs of voltages. Voltages always have a polarity. One terminal is at a higher voltage than the other. Since we don't always know which terminal is at the higher voltage before we make a measurement, we need to be able to interpret our measurements relative to an assumed polarity. When we measure a voltage, the terminals labeled with a negative sign, 1 minus and 2 minus, connect to the terminal which is assumed to be at the lower voltage. The terminals labeled with a positive sign, 1 plus and 2 plus, connect to the terminal which is assumed to be at the higher voltage. If the positive lead of the voltmeter really is connected to the higher voltage in a circuit, the voltage difference displayed will be positive. If the leads are reversed, so that the negative terminal is at the higher voltage, the displayed voltage will be negative. In other words, reversing the leads changes the sign on the displayed voltage. Suppose, for example, that we want to measure the voltage difference between the terminals of this 9-volt battery. We know which terminal should be at the higher voltage. The terminal with the plus sign by it should be 9 volts above the voltage of the other terminal. If we connect the positive lead of our voltmeter to the higher voltage terminal and the negative lead to the lower voltage terminal, we measure a positive 9.7 volts. Reversing the leads should simply reverse the sign of this number. We get negative 9.7 volts. Now let's use our voltmeter to measure the voltages in the circuit we created in our voltage instrument tutorial. Our circuit schematic is shown here. We're going to measure the two voltages, V1 and V2, the voltage across the diode and the voltage across the resistor as shown in the diagram. Notice that we've indicated these voltages to have an assumed polarity. The assumed polarity tells us how to interpret a positive number displayed by the voltmeter. Our diagram shows that the positive terminal for V1 is at the diode's anode, so we'll connect the positive terminal of channel 1 of our voltmeter here. The diode's cathode is the negative terminal. We'll use 1 minus here. Likewise, when we measure V2, we'll connect the positive voltmeter lead of channel 2, 2 plus at this point, and the negative terminal of channel 2 at this point. Here's the circuit we created in our voltage tutorial. To make the measurements we indicated on our previous slide, we'll connect channel 1 plus to this terminal, 1 minus to this terminal, 2 plus also to the terminal where the resistor and the LED are interconnected, and 2 minus to this terminal. Now we can apply voltage to our circuit and measure the voltages V1 and V2. We'll use the voltage instrument, of course, to apply power. The voltmeter indicates that channel 1 has a voltage of 2.1 volts approximately, and channel 2 has a voltage of negative 2.9 volts.